everyone. We're going to evaluate the improper integral or state that it diverges. This is improper because one of our limits, namely our lower limit, is infinity, and we have 2 dx divided by x squared minus 1. Now we're going to have to integrate this. So the first thing I want to do is just do a little refresher with partial fraction decomposition. So if I want to simplify this so we can integrate it, I'm going to write this as x minus 1 times x plus 1 and split this fraction up using partial fraction decomposition. This should be more of a refresher for you, but I just want to do it real quick. So basically we're going to clear the fractions by multiplying through by our denominator here, x minus 1 times x plus 1. And that gives us 2 equals a times x plus 1 plus b times x minus 1. All right. So simplifying, we get 2 equals ax plus a plus bx minus b. We're going to get 2, and we're going to factor out an x, and we get a plus b. And then if you want, put these two together, that's going to be a minus b. Now basically what we have is, if you want to add 0x here, this is your constant. So we're going to equate coefficients. So for the 0x, for the x's here, we have 0 equals a plus b. And for this one, this is your constant, so we have a minus b equals 2. Now solving our system, we add both of these, we get 2 equals 2a. The b's will cancel out, so you get a is going to equal 1. If your a is 1, then we have 1 plus b equals 0, or you can use this one. And so b is going to be negative 1. Now I'm just going to substitute up here because, again, this should be more of a refresher for you. So your a is 1 and your b is negative 1. So I'm just going to write this as negative here 1. So that's how we're going to rewrite our integrand. Now let's go ahead and get started and use our formula. So we have negative infinity for the lower limit, and we're going to use this, rewrite our integral as a limit and solve accordingly. So we're going to write this as the limit as b approaches negative infinity, and this is going to be from b to negative 2, so I'm changing these two. All right, and then I'm going to rewrite my integrand as 1 divided by x minus 1 minus 1 divided by x plus 1 dx. All right, from there, we're going to integrate this. So we have the limit as b approaches negative infinity. This piece is going to be ln of x minus 1 minus ln of x plus 1. And we're evaluating from negative infinity to negative 2. Now I'm going to go ahead and write this as a single log. So now we have the limit as b approaches negative infinity of ln of x minus 1. We can go ahead and put absolute values here. Divided by x plus 1 from negative infinity to negative 2. Now, when you get this, what you're going to get is you start with this piece here. So you're going to get this equals, the limit is going to be, let's write it out. The limit as b approaches negative infinity, and it's going to be ln of, when you plug in the negative 2, you're going to get negative 3 divided by negative 1 minus ln of b minus 1 divided by b plus 1. All right. So when you plug in negative infinity here, this is just going to go to 0. So what we have left is this. So our answer is going to be ln of 3 when you because you have two negatives here, so that's going to make a positive. And that is your final answer. Thank you. Have a nice day. Bye-bye.